Hey there, this is the final lesson of Chapter 2. This is all about solving absolute value inequalities. For our opener that we're going to be talking about in class, you need to go over each of these. So take a second, pause this video, and do this yourself. Again, pause this video and do it yourself. Alright, now that you've paused the video, I'm going to show you guys the answers to these. So the two answers you should have gotten here, again, the highlighted sections are away from each other, so it's an or statement. These ones, the highlighted section is together. All right, so our target today is I can solve absolute value inequalities. We've already done inequalities. We've done absolute values back when we did equations, which remember is where we had the two straight lines. We had to separate them. There are a lot of notes on this page, so I'm just gonna walk through this as you should be writing this down. You should write down all of this paragraph and then all of these paragraphs as well. The thing underneath here, right there, that's not as important. The biggest thing is that an absolute value inequality is just an inequality that has an absolute value expression. Anything that has a less than symbol is always going to result in and. It has a greater than symbol, it's going to result in ors. To solve these, you simply take whatever is inside the absolute value and you treat it like you would a compound inequality. So this one, because it's less than, it's going to be an and statement. We have to have both the values shown at either end, same as this one. Because it's a greater than symbol, it's going to be an or statement. Again, the major concept here is that anytime you have an absolute value that deals with a less than, it's going to be an and statement. So really these ones go together. And anytime you have a absolute value that deals with a greater than, it's going to deal with an or statement. Let's take a second to see what that looks like. So for this first one, it's a less than statement, meaning an and statement will need to come from this. So this should now turn into the following. X plus 7 is in the middle. It's less than or equal to 2. And then it's greater than or equal to the negative 2. From here you would solve it down, which you'd simply subtract 7 from both sides. So you'd be left with negative 9 is less than or equal to x, which is less than or equal to negative 5. You could easily graph this on a line as well by making your number line, putting your values at negative 5 and negative 9. They are both, in this case, going to be closed circles, and the lines would be between. You would want to fill in a few more of these other values inside here as well. For our next one, again, this one is an and statement. And as we read the one on the right, it says the absolute value is less than 0. Absolute values have to be positive numbers, so they cannot be less than 0. So right away, this one is a no solution. Because again, this is not a true statement. All right, the next one here, we are going to be working through this one one at a time. So these are all greater than. See, there's going to have or statements to them. So I've split these now. So they have the two symbols because it's going to be an or in the end. Now notice that in this case, the original piece I kept exactly the same. C minus 1 is greater than or equal to 5. However, when I did the less than and I made the negative 5, just like anytime we have to introduce a negative and multiply it through, we have to change the sign. So that's why this changes from greater than to less than here. I'd go ahead and I would solve these out. So I'd be left with C is less than or equal to negative 4, and C is greater than or equal to 6. Meaning on my number line, my two values I'd have to go at are at 4 and at 6. They would both be closed, and pointing away from each other because these are or statements. For the next one, it says the absolute value is going to be greater than a negative number. This is going to be true for all cases because any absolute value is always positive and all positives are always greater than negatives. Therefore, this one here is going to be true, and it will have all real solutions. In the past, we also called this infinite solutions. Okay. For C, we'd have to isolate it. We have to get the absolute value by itself first. So it would look like this. So the first thing I did is I subtracted the 1, so I got 20. Then I divided both sides by 4, so I got the 5. So I'm just left with the absolute value of 2x minus 5 is greater than 5. Because it's a greater than, it's going to need to be an or statement. So I'd just simply split it again. And we're left with these two values of 2x minus 5 is greater than, or 2x minus 5 is less than negative 5, and 2x minus 5 is greater than 5. As we work these through, we'd have to add 5 to both sides. So we get 2x is less than 0, and we also get 2x is greater than 10. Divide both by 2, so we get x is less than 0 and x is greater than 5. Again, to do my number line, I would simply draw my number line, draw my two anchor numbers, wherever they may be. In this case, it's going to be or statements, so they're going away from each other. All right, our last example here just talks through how to solve a word problem. Before we solve it, remember that the absolute deviation just simply means that the x minus a given value is the absolute value that gives your absolute deviation. So this one gave an example where you're buying a new computer. Here are 10 prices of different computers you could buy. You're willing to pay the mean price with an absolute deviation at most of $100. There's a lot going on there. That simply means that you're willing to pay the average of these plus or minus $100 is really all it comes down to. So the first thing you have to do is average. When you add up all 10 of these, you get 6,640. You divide that by 10 to get your average of $664 per computer. This is going to be absolute value because it's going to be an absolute deviation. And you're willing to spend at most $100. So that means you can go up to 100, but you can't go over. So it's going to be less than or equal to. It's a less than, so it's an and statement. So you put the values on either side that are positive and negative. Add your 664 to both sides, and your final answer becomes values between $564 and $764. Meaning that 890 you would not be able to do. 750 would, 650 would, and the 825 here you'd be willing to do. You also would not be willing to do the 450 because that would not fall in there, or the 370. So those other 6 prices in the 600s and the 700s you would be willing to pay for it. Our homework is here and it's posted in our Canvas page. It's 20 problems. It should not take too long to finish. And lastly, just so you guys are aware again, this has been stated earlier in the week, it's just being restated now. The Chapter 2 test is going to be next week, most likely on Wednesday. Use this weekend to get caught up on any lessons, any homework, and any quiz corrections you have to do. Next week should strictly be used for the review and the test. If you're trying to get caught up on notes, that's not how you should be doing class. You should already be caught up before that week.